Unit 4 Fourier transform, problems on Fourier transform. So the first problem is obtain the Fourier transform of obtain Fourier transform of delta function. So x of t is equal to delta of t. Now we have to draw here the delta function. So first we draw the delta function here. This is t equal to 0. It is x of t is equal to delta of t. So this figure shows it is delta function. Now according to the definition of Fourier transform, right here, definition of Fourier transform, we can write x of f is equal to integration minus infinity to infinity x of t e raised to minus j 2 pi f t dt. So here x of t is what? Delta t. We write here x of t is equal to delta t. So above equation becomes x of f is equal to minus infinity to infinity delta t e raised to minus j 2 pi f t dt. This is equation number 1. Now here the delta function is present only at t is equal to 0. So we cannot calculate integration directly. For that we have to save the equation 1 and we can use the shifting property of the delta function. That is, we can shift this delta t and e raised to minus j 2 pi of ft. We write here delta function is present from this figure. Delta function is present only at t is equal to 0. So we cannot calculate integration directly. So to solve equation 1, we have to use shifting property. Shifting property of delta function. So this property, it becomes minus infinity to infinity, it becomes here, okay, it is x of t and it is delta t is here, that is delta of t minus t 0, which is x of t 0. So here x of t0 means the value of xt at t equal to t0. We write here x of t0, that is value of xt at t equal to t0. So compare equation 1 and 2. Equation 1 and 2. So x of t is equal to e raised to minus j 2 pi ft. This is equation 3. And delta of t minus t0 is delta of t, equation 4. So from equation 4 we can say that t0 is equal to 0. Now from equation 2 the answer of integration is x of t 0. So it is the value of x of t at t equal to 0, t equal to t0. So in this case t0 is value of this is 0. So put this t equal to 0 in equation 3. Therefore x of t equal to 0 so x of t equal to 0 equal to e raised to 0 equal to 1. Therefore x of f value is 1. So Fourier transform of delta of t is 1. This is the answer. So this problem was asked in exam for 4 marks. Now the next problem is obtain the Fourier transform of second problem. Fourier transform of unit step, that is x of t is equal to u of t. So first we draw the unit step signal here. Now we write here, it is defined as u of t is equal to 1 and 0. This is for t greater than equal to 0 and this value for otherwise. This is unit step signal. This is standard definition. So according to definition of Fourier transform, x of f is equal to minus infinity to infinity x of t e raised to minus j2 pi f t dt. So the value of x of t u of t is 1 from 0 to infinity. Now x of f becomes 0 to 1, 1 into e raised to minus j2 pi f t dt. So we solve this integration now. It is equal to e raised to minus j2 pi f t divided by minus j2 pi f, integration value 0 to infinity. So it is e raised to minus infinity minus e raised to minus 0 minus j2 pi f. So it's a, but what is e raised to minus infinity? It is 0 and e raised to 0 is 1. So the equation becomes x of f is equal to 0 minus 1 by minus j2 pi f, that is 1 by j2 pi f. So this is the answer. You can write u of t, its Fourier transform is 1 by j2 pi f, or we can say 2 pi f means omega, 1 by j omega. This is the answer. So this problem was also asked for 4 marks in exam. Okay, next problem. Obtain the Fourier transform. Third problem. Of x of t is equal to e raised to minus at u of t. So it is decaying exponential. So first we draw the diagram for decaying exponential. This is t, it is x of t, it is e raised to minus at u of t. This is 0. So now according to the definition of Fourier transform, we write here according to the definition of Fourier transform, x of f is equal to minus infinity to infinity x of t e raised to minus j pi f t dt. So here if the given signal is multiplied with u of t, then the limits of integration will be from 0 to infinity. So here the given function is multiplied by u of t. So the limits will be from 0 to infinity because u of t exists from 0 to infinity and its value is 1. So we write the equation x of f is equal to zero to infinity e raised to minus at e raised to minus j 2 pi f t dt. So it is 0 to infinity e raised to minus t a plus j 2 pi f into dt. So we can apply this limit to this equation. So e raised to minus t a plus j 2 pi f divided by a plus j 2 pi f integration 0 to infinity. So we write here e raised to minus infinity. We applied the limits now. E raised to minus 0 minus a plus j 2 pi f. So it becomes so e raised to minus infinity is 0 and e raised to 0 is 1. So 0 minus 1 divided by this. So we get 1 by a plus j 2 pi f. So we can write integration or Fourier transform e raised to minus at u of t. Its Fourier transform is 1 by a plus j 2 pi f. This is the answer. So this problem was asked for 3 marks. Next problem. Obtain Fourier transform of signum function. It is x of t is equal to hgn of t. So first we draw this signum function. So we'll draw the diagram for this. So mathematically the signum function can be written as Sgn of t is equal to, this is 1 and minus 1, this one is for t greater than equal to 0 and t less than not equal to less than 0. Okay, now in terms of unit step the signal function can be expressed as, we write here, in terms of unit step signal function can be expressed as x of t is equal to Sgn of t 2u of t minus 1. This is equation 1. So we draw the diagram for this. We draw the diagram for this equation. First we draw this is t, it is 0, it is 2, infinity, it is 2u of t. Next it is t, this is 1, it is infinity and it is minus infinity. So this equation minus this equation, and the answer for this is it is minus infinity, it is plus infinity. So this function is Sgn of t is equal to 2u of t minus 1. We have drawn we draw the diagram for this Sgn of t equal to 2u of t minus 1. Now differentiating equation 1, we write here, differentiate equation 1, we get d by dt of x of t is equal to d by dt of 2u of t minus 1. So it becomes 2 is constant, d by dt of ut minus d by dt of 1. So d by dt of x of t is equal to 2 d by dt of u of t. Now derivative of unit step is what? Derivative of unit step is delta function. Therefore d by dt of xt is 2 delta t. This is equation 2. Now we have to take the Fourier transform of this equation 2. So the Fourier transform d by dt of xt is j2 pi f into xf. So the Fourier transform of delta t is 1. We write here Fourier transform of delta t is 1. Therefore j2 pi f into xf. This is Fourier transform of